And here we are, Chapter 5 of CCNA 4, Network Security and Monitoring. It's a pretty short slide deck, so this might go kind of quick. We'll try to add some stuff in to further clarify topics if we can. We're going to be talking about LAN security, how to mitigate LAN security, SNMP for net monitoring network operations, and SPAN, your Cisco switch port analyzer. And we start here, LAN security. These are some common attacks you'll see: Cisco Discovery Protocol reconnaissance attacks, Telnet, MAC address flooding, VLAN, DHCP attacks. We need to know how to mitigate these attacks, as well as securing our administrative access and securing your port access. So we'll talk about the techniques for doing so. So one that is not on this list is the CDP the Cisco Discovery Protocol reconnaissance attack, which is where someone's intercepting your CDP broadcasts. Broadcasts from CDP are unencrypted. They include IP address information, iOS software version, platform capabilities, the native VLAN. So there's a lot of information in CDP broadcast that shows an attacker what your network infrastructure is. So if you want to mitigate that, you can either turn off CDP globally with a no CDP run command, or if you want to turn it off on a port, you can go to the port and do a no CDP enable, and you can do that. On the other side, you can also turn it back on by saying CDP run globally, or go to a port and do CDP enable, and that would work as well. Telnet is also not listed on there, but a Telnet attack would be a brute force password attack that they'd try on Telnet to try and guess the password, because all you need is the password for Telnet. And you could do a Telnet denial of service attack, which is just going to render Telnet services unavailable, and cripple them, so the actual network administrator can't get to the switch. But we learned back in CCNA, I want to say 2, maybe 2, that we use SSH rather than Telnet typically, and that's one way to prevent a Telnet attack. The other ways use strong passwords, limit access to VTY lines using access control lists. So those are a few things you can do to mitigate a Telnet attack. We've talked about mitigating MAC address table flooding attacks back in CCNA 2. Basically what an attacker is trying to do is flood the MAC address table on a switch so that the switch no longer can associate MAC addresses with a certain port and ends up broadcasting everything. That way the attacker can intercept traffic. If you want to prevent that, we can limit the number of MAC addresses that each port can store. We can go to a disabled state if we exceed a certain number of MAC addresses. There's a few things we can do in terms of port security that we did in CCNA 2. So if you want to take a look at that again, you can. But basically, we just enable port security, limit the amount of MAC addresses per port, and that should be enough to stop it. Your VLAN attack is basically going to be attackers spoofing that they're a switch and trying to gain access to multiple VLANs that are connected to a network by exploiting Cisco Dynamic Trunking Protocol, DTP. So if you want to mitigate that attack, you're going to explicitly configure your access links, not leave them in auto states, disable automatic trunking, manually enable trunk links, disable unused ports, change the default native VLAN, and implement port security to mitigate that attack. Okay. We've talked about DHCP spoofing, in which the attacker tries to pretend he's a DHCP server, DHCP starvation, so that devices on your network can't get an IP address, basically like a denial of service. We've got the DHCP snooping command that we've used to mitigate that back again in CCNA2. Remember, DHCP snooping basically validates DHCP messages received from untrusted sources and filters out any invalid messages, hopefully stopping your attacker. Cisco devices are going to require some form of authentication to gain administrative access. And this AAA authentication, authorization, and accounting framework is used to help secure device access. AAA authentication can be used to authenticate users for administrative access, or it can be used to authenticate users for remote network access. Local AAA uses a local database for authentication. This method is sometimes known as self-contained authentication. This method stores usernames and passwords locally in the Cisco router, and users authenticate against the local database. And this form of authentication is ideal for small networks. The other kind is server-based AAA authentication. It's a more scalable solution. The router accesses a central AAA server. That AAA server contains the usernames and passwords for all users and serves as a central authentication system for all infrastructure devices. With our server-based AAA, the 802.1x protocol can be used to authenticate devices on the corporate network. The 802.1x standard defines a port-based access control and authentication protocol. This is supposed to restrict unauthorized workstations from connecting to the LAN through publicly accessible switch ports. The authentication server authenticates each workstation that is connected to a switch port before making available any services offered by the switch or the LAN. Okay, and we'll move on from there. Some best strategies to help secure Layer 2 SSH, SCP, SSL, SNMP, which is what we're going to get into, the Simple Network Management Protocol. Always use strong passwords. We talked about Cisco Discovery Protocol, securing telnet access. We should probably just use SSH instead. Dedicated management VLAN, where nothing but management traffic resides. We talked about that when we were setting up VLANs. Use access control lists to filter unwanted traffic. And then we're going to talk about the Simple Network Management Protocol. So SNMP was developed to allow administrators to manage nodes such as servers, workstations, routers, switches, and security appliances on an IP network. It enables network administrators to monitor and manage network performance, find and solve network problems, and plan for network growth. This is an application layer protocol that provides a message format for communication between managers and agents. So we've got SNP managers, SNP agents, and the management information base. So the SNP manager is part of the network management system, or NMS. The SNP manager runs SNMP management software. The SNP manager can collect information from the SNP agent using an action called get, which you'll see down here. It can change configurations on an agent using an action called set, which you see down there. Okay. In addition, SNP agents can forward information directly to a network manager without being asked for them by using this trap message that can be sent again without the get being sent in the first place. So this manager is going to send that get in set. Agent's going to send the trap message back. Okay. The SNMP agent and MIB reside on the SNMP client devices. The management information base resides over here. Network devices like switches, routers, servers, firewalls, workstations are equipped with an SNMP agent software module. The management information bases store data about the device and operational statistics and are meant to be available to authenticated remote users. The SNMP agent is responsible for providing access to the local management information base, or MIB. The SNMP manager pulls agents and queries for the management information base for the SNMP agents on UDP port 161, and tramps to the manager are sent through UDP port 162. So those port numbers may be significant in testing. These are the different versions of SNMP. We've got version 1, 2C, and 3. V1 of the Simple Network Management Protocol is a full internet standard defined by the RFC and defined in RFC 1157. V2C is defined by RFCs 1901 and 1908. It utilizes community string-based administrative framework. And V3, which we have the longest explanation for, which is the one you'll use most often, defined by RFCs 2273 to 2275, provides secure access to devices by authenticating and encrypting packets over the network. It includes a few security features, message integrity to secure that the packet was not tampered with in transit, authentication to determine that the message is from a valid source, and encryption to prevent contents of a message from being read by an unauthorized source. So you can see the table, the specifications that go into each one. V1 and V2, you're going to have a community string for authentication, which means that there's no username. You just have a password you're going to have to enter in. Your access is going to be based on an access control list, actually, as well as a password when you're using this community string. Then we go to 3. You're going to have a username that you're going to gain access with. Then we've got the version with authentication. We've got an MD5 or SHA for that, those algorithms for authentication. Then we have the version with data encryption. So just know which goes with which. Okay, so that's a decent chart to study. And we'll go into configuring SNMP. So we're going to configure community string, location, system contact, restrict SNMP access, specify the recipient of SNMP traps, enable SNMP traps on the enable traps on the SNMP agent. So we'll go through all those commands and see how it works for SNMP v1 and v2 and v3 as well. All right, configuration. First, we're going to configure the community string. You've got the command for SNMP server, community, and you're going to give it some name. So we've given it this name here, Botanog. You're going to determine whether it's read-only or read-write with that command there. And you're going to input the access control list name there. It doesn't necessarily have to be SNMP underscore ACL. It can be whatever the access control list name is going to be. Okay. Noting your location in your document, in your contact, that's optional. So these two steps are optional. If you want to put in SNMP location, you're going to put in whatever that location is. And again, this is just documentation. It's not going to affect the operation of SNMP. So it's just for your eyes pretty much. It's not for the function of SNMP. SNMP server contact, put in whatever the contact you want it to be is, and then we're coming down to SNMP server host. Now this SNMP server host is only if you want to configure a host that is going to receive traps messages. So if you are going to put an SNMP server host, the IP address of that host, you've got your version. Which version is it? Is it 1, 2C, or 3? If it's going to be 3, you're also going to input whether it's authorization, no authorization, privileged, from that chart we just saw. So you're going to have to input that as well. And you'll probably see that in your lab. As well as your community string, which is going to match the community string that you created up here. Okay. And if you have a host set up to receive traps messages, then you're going to come down here, SNMP server enable traps. Okay. Then you'll define who has access to SNMP with an access list that you create down here. So IP access list SNMP blah, permit, I believe it should say permit host 192.168.1.3, or at least have a wildcard mask out there, but that's not what they have here. Some other examples we have, if you go over to your SNMP manager, there is going to be some type of software set up there. This is an example of what that software might look like. The option to enable traps there. Okay. SNMP manager display, you can't really see too much there, but on your device, you've got your show SNMP command. It shows your contact, your location that you documented, how many trap PDUs there's been. Your SNMP logging is enabled, the IP address there, your port. We got show SNMP community, so your community name, community security name, the access list that you've set up. So all of those are to verify your SNMP configuration. And here we have our steps to configure SNMP v3, which is going to be a little different because we don't have that community string. We've got a couple other factors we've got to consider. So how it's going to start off is you're going to define your access list first. So IP access list standard, then your ACL name, permit whatever device you're going to permit, whatever range of devices you're going to permit with that statement. Then you've got your SNMP server view. You're going to give it a view name of some sort. Then you're going to define your MIB object identifiers here from that tree that you'll see in your readings. In fact, I'll bring up the tree now. So some examples you have ISO, org, DoD, internet, private, so on and so forth. So it could be any of these object IDs that you put in there. And you'll see an example of that when we configure it. Then you're going to have your SNMP server group with your group name, your version number here, which in this case is v3, that's what we're using. What type of v3 are we using? Is it no authorization, no privilege? Is it authorization privilege? Or is it just privilege? So you've got those three different options that we saw in the table a couple slides back. The view name, which is the view name we just defined up here. Access control list number or name, whatever it is you set up there is what goes down here. Okay, so that's configuring the SNMP group. Then configure a user as a member of the SNMP group. You're going to have SNMP server user username, okay, v3. Then your authentication with your encryption here, MD5 or SHA, authorization password or auth password, priv or whatever type you're using, and your encryption type here, then your encryption password, priv password. Okay, so you're going to have all that to set up. What it's going to look like in action is right here. So you've got the access list name created, your view name that you create here. And when you're looking at these slides, realize that anything in all caps really, well, even things that aren't in all caps, but especially things in all caps are things you're going to create on your own. Okay, so we create this SNMP-RO. That's the MIB object ID is ISO, which you saw in the tree included. SNMP server group, group name admin, v3, priv, read or write here, depending on what you're going to do. Since we're doing read only, we put read. Okay. Then we have the view name there, access, which is just for your ACL that we created, permit admin matches up there. Okay. SNMP server user, we're going to create the username Bob admin, v3. We're using SHA. You got your authentication password. And we're going to use AES encryption 128. We're saying that the SNMP software only supports this, even though your router could support up to AES 256. Well, they'll say the management software only supports 128. We put that in there, and you put your encryption password there at the end. Okay, so that's going to be a lot to remember, but that's how it's set up. I'll leave it there for a second. So if we jump back to the slides, we've got securing SNMP v3. We just went through all this in the reading, so we set it up. You'll have some labs on it. Require a lot of practice because there really are a few different ways you could set it up, different factors you could incorporate here. So those will be important labs to take care of in class. The last thing we have in this chapter is Cisco Switch Port Analyzer, or SPAN. So packet mirroring, which we have here, is going to duplicate packets that are sent on your network to some device that is monitoring the network. Okay, usually through something like Wireshark, you'll only be able to monitor traffic on your device. Okay, so this laptop down here would only be able to manage monitor traffic between S1 and the device. But with packet mirroring, S1 can send traffic, duplicate traffic, to some monitoring device down here, even if it's between two totally separate devices, so you can monitor traffic on your network. Got some SPAN terminology. We know what ingress and egress ports are, hopefully. Ingress port would be traffic going into, egress traffic going out of a switch. Okay. We also have source and destination SPAN ports. So source ports are going to be the ports that where traffic is monitored to be sent to the device that will be analyzing the traffic. So these two ports here, for instance, are going to be, their traffic is going to be sent to our device down here, which is going to monitor traffic. Your destination port is the port that traffic is sent out through for analyzation. So it's reading basically on these two ports and sending the traffic down to our device down here so we can analyze or monitor the network. Your SPAN session is the association of your destination port with one or more source ports up here, as you can see there. And then you've got your source VLAN, which is the VLAN being monitored for traffic analysis. Remote SPAN is going to allow us to have source and destination ports on different switches. Okay, so you're basically down here separated by one switch from the ports on which you're going to monitor traffic on. Okay. So you've got your same basic sources and destinations, but you do need a special VLAN set up to communicate that traffic through one switch to another. and that VLAN needs to be allowed on the trunks between each switch. Okay, so what we're going to do to set that up is right down here. So you've got that. It's going to be configured with the remote span VLAN configuration command. So remote span, then that VLAN. And that VLAN is going to be defined on both switches down here. Okay. And that VLAN has to be allowed through the trunk port between the switches. So that's going to have to be set up there as well. I don't believe you will have to set this up in your labs. All you'll have to set up is your normal span. Okay, and we're going to go over that right now. So our goal here is to monitor the traffic between F01 and this PCA, and have that sent to our packet analyzer over here. Okay, so we're just going to set up a source port, one source port in this situation, and set up a destination port. So we got monitor session, some number, whatever session number you want this to be associated with. So they use number 1. Source, you could use the interface or the VLAN, depending on what you are looking for there. So we've got interface, that could be VLAN, some VLAN number as well. So we've got interface, fast Ethernet 01, because that's what we want to monitor. Okay. And we just have to determine a destination. Where are we going to send that duplicate traffic to? We're going to send it through F02. So monitor session 1, destination, interface, fast Ethernet 02. That's pretty much it. That's how it's going to be set up, and I believe that's all you'll have to really set up in your labs is something simple like this. You might have a couple more source ports that you need to set up on a switch, but that should be about the extent of it. Okay. And what does this allow you to do? It allows administrators to troubleshoot network issues. You use span to duplicate and redirect traffic to a packet analyzer. That's what we're doing. That's the purpose. Administrators can analyze traffic from all devices to troubleshoot suboptimal operations of network applications. All right. So that's about that. I think that's it. That is it. So we had span, we had our SNMB, I'm sorry, and we had our LAN security that we went over in this chapter. So that's it for chapter 5. Not too long a video, and I think we should be good to get chapter 6 cranked out tomorrow, hopefully.